If you and I were asked to prepare a meal, there are a few questions that could go into it, including why us? We're network engineers. or if we can cook, we might ask the question, what are the recipes involved, the instructions, and what components do we have, or ingredients for those recipes? Do we have everything we need? Well, we have the same kind of scenario with networking. If we want to implement networking, we need to know what services or features and functions are we looking for. So in preparation for bootstrapping and getting all of our gear up and running, let's take a look at the big picture regarding some of the networking and features and services that we are going to want to incorporate as part of our network design. So here is the lab topology that we walked through in the previous set of videos regarding building a lab in EVE-NG. And currently this router is running, but the Palo Alto firewall is not. So because that does initially take several minutes to boot up, I'm going to right click and start it. And it's got no configuration whatsoever. We'll come back to that in the next video when we start bootstrapping it. But that'll give it a chance to have a little bit of a head start on getting booted up and ready to go. So let's take a look at some of the features that we're going to want to implement. On these interfaces, Ethernet 1.1, which goes to the inside, and Ethernet 1/3 that goes to the outside, we are going to want to configure those in this lab topology as layer 3 interfaces. So we'll have a whole separate discussion on other options, including layer 2 interfaces and tap interfaces and beyond. But for this lab topology, for this Palo Alto firewall, we want these interfaces to be layer 3, which means that they are going to have an IP address associated with them. And this one's going to be 23.1.2. And it's going to be .11. And Ethernet 1.1 is going to be 10.1.0.11. And on the management interface, it's also going to be .11. It'll be 192.168.1.11. Regarding routing, this Palo Alto firewall with these layer 3 interfaces is going to know about 2 directly connected networks for the data plane, which is the 10.1.0 network and the 23.1.2 network. But it's not going to know anything beyond that. So for the routing table on the router, we also are going to want to have a default route. And this little router here is at .1. So when we configure a default route for the Palo Alto firewall, we're going to say the route to 0.0.0.0/0. The default route is going to have a next hop of 23.1.2.1, which is this guy right here. And then this router, with its connectivity to the real internet, and also it's doing port address translation, we'll be able to take any traffic sourced from the 23 network and be able to forward that out to the internet. And then the replies from the internet would come back through that router as well. And regarding routing, there's basically 3 ways to learn about how to reach a network. We can be directly connected, and that's what's happening with the 23.1.2 network and the 10.1.0 network. Is because the firewall is directly connected to those networks with layer 3 interfaces, it says, hey, I know how to reach those networks. I'm directly connected. Another option would be configuring static routes. An example of a static route could be the default route, which we statically configure with the next hop address. Or it could be specific subnets that we're pointing to with static routes. And the third option is dynamic. So we could use routing protocols like RIP or OSPF or BGP. And that way, the firewall working with a routing protocol can dynamically learn routes from other devices who are also running the same routing protocol. And that way, it can dynamically learn about how to reach remote networks that aren't directly connected via the dynamic routing protocol, such as OSPF. Another feature that we may want to incorporate on our Palo Alto firewalls is DHCP. I'll add that over here. So DHCP is a fantastic way of dynamically handing out IP addresses to DHCP clients. So if we want to make this firewall a DHCP server, we can, and we can set up a range of addresses. And that way, devices over here on the 10.1.0 network, and we'll call this headquarters site, they can go ahead and get an IP address dynamically from the Palo Alto firewall that's acting as a DHCP server. There's also a gotcha if we have a client that does get an IP address. Let's say he's at .51, and he gets an IP address. He learns about the default gateway, which is 10.1.0.11, and if it forwards traffic out and it needs to be routed out to the internet, the Palo Alto firewall, assuming it's allowing that traffic, the Palo Alto firewall will use its default route to send it, and then this router will go ahead and send it. However, if that packet shows up as 10, a source address of 10 on the public internet, that is an example of a private IP address space, which the internet, the real internet, will not route. They don't forward traffic that's in any of the RFC 1918 private address spaces. So in addition, what we'd want to do is we'd want to go ahead and set up network address translation services on the Palo Alto firewall. So I'll add that to my list over here, NAT. So at a bare minimum, as the clients are being sent through the firewall, we need to swap out the source address. And what we can use temporarily is we can do PAT, where port address translation, where we're going to swap out the source address with whatever address is being used here on the outside interface. And then one last piece of making all of this work is a security policy. Because by default, the firewall has an attitude, and it has one word in its mind, and it is no. Traffic that's trying to go like from the inside to the outside, which is an example of traffic that's going between two different zones. The default attitude is no, I'm dropping this traffic. So the security policy, at a bare minimum, has to say, that's okay, let that traffic go. So those are examples of a few basic technologies that we're going to want to implement just to have basic traffic flow from the client going through the Palo Alto firewall. So in this set of videos, we're going to go through the fast track for getting most of this implemented for basic connectivity. And again, the reason for that, which is pretty important, is that once we have the basic connectivity and things are working, it's at that point when routing is working and everything else that we can start adding on the next generation features, like looking for malware, looking for spyware, looking for intrusions, or controlling traffic based on what type of application is being used. All those advanced features rely on the basic functionality first of routing and forwarding to be in place. So now that this Palo Alto firewall has had a moment or two to power up, in the next video, I'll walk you through the bootstrapping of the Palo Alto firewall from the ground up. See you there in just a moment. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.